There is a window design that heats your home for free. It requires no solar panels, no heat pumps, no gas lines, no electricity. It collects heat from the winter sun and stores it inside your home all night long. And it has been doing this for over 2,000 years. Yet right now, while the $200 billion window industry sells you triple-glazed plastic frames that cost $3,000 per window and still leak heat every single night, this design sits forgotten. Not because it stopped working, not because something better replaced it, but because you cannot charge someone a monthly bill for sunlight. So what is it? How does it work? And why did we stop using it? Let's find out. To understand this system, we have to go back to ancient Greece. Around 400 BC, the Greeks discovered something that every intelligent builder immediately understood. A south-facing opening in a wall does not just let in light. It lets in heat. Free heat. Delivered every single day by the most powerful energy source in the solar system. The Greeks built entire cities around this principle. South-facing colonnades captured winter sun and blocked summer sun using carefully calculated overhangs. The Romans took this further. They invented the first glass windows specifically to trap solar heat inside buildings. They called south-facing sunrooms the heliocamenus, the solar furnace. Wealthy Romans built entire wings of their villas around this principle, and Roman law actually protected a citizen's right to sunlight access. If your neighbor built a structure that blocked your south-facing windows, you could sue them. They called it the right to light, because they understood that sunlight was not just comfort, it was fuel. Free fuel that fell on every roof and every wall every single day. Medieval European builders carried this knowledge forward. Gothic cathedrals used massive south-facing stained glass windows, not just for beauty, but for passive solar heating of enormous stone interiors. Monastery gardens were designed around south-facing glass and stone walls that extended the growing season by weeks. For 2,000 years, this knowledge was built into every intelligent structure on Earth. Then we discovered fossil fuels, and forgot everything we knew. The modern version of this ancient system is called the Trombe Wall, named after French engineer Félix Trombe, who rediscovered and documented it in 1964. But the principle behind it is far older than Trombe. Here's what it is. A south-facing glass panel mounted a few inches in front of a dark-colored wall of high thermal mass. Stone, concrete, brick, or earth. The glass lets sunlight through and traps the heat inside the air gap. The dark wall behind absorbs this concentrated heat all day, and then slowly releases it into the home all night. It is a solar battery built into the wall of your house. And the thermal performance data is extraordinary. A properly designed Trombe wall can provide between 30 and 70% of a home's annual heating requirements in cold climates, with zero fuel, zero electricity, zero moving parts. The United States Department of Energy studied Trombe wall performance across multiple climate zones and confirmed consistent heating cost reductions of up to 50%. Yet fewer than 1% of American homes use any version of this system. Here's exactly how it works. The system operates on 3 basic principles: the greenhouse effect, thermal mass, and convective air circulation. Start with the greenhouse effect. Glass has a remarkable property. It allows shortwave solar radiation to pass through it freely, but it blocks long-wave infrared radiation, which is heat, from escaping back out. This means that sunlight enters through the glass and strikes the dark wall behind it. The wall converts this solar radiation into heat, and the glass traps that heat inside the air gap. The air gap between the glass and the wall can reach temperatures of 140 degrees Fahrenheit on a clear winter day, even when the outside temperature is below freezing. Now thermal mass takes over. The dark wall behind the glass is built from a dense high-mass material: stone, brick, concrete, or adobe. These materials absorb heat slowly and release it slowly. As the air gap heats up throughout the day, the wall absorbs and stores this thermal energy deep within its mass. Then, as night falls and the air gap cools, the wall begins to release this stored heat, but it releases it inward, into the living space, not outward into the cold night air. Finally, convective circulation distributes this heat through the room. Vents at the top and bottom of the wall allow cool room air to enter the gap at the bottom, get heated by the wall, rise to the top, and flow back into the room as warm air. A natural convection loop that circulates heat without a single fan or pump. The result is a wall that collects free solar heat all day and delivers it into your home all night, with zero moving parts, zero electricity, and zero fuel cost. So if this system is this effective, why isn't it on every home in America? The first reason is orientation. A Trombe wall requires a south-facing surface with unobstructed winter sun access. Homes surrounded by tall buildings or dense tree cover on the south side will see reduced performance. And in very cloudy climates, the system produces less heat simply because there is less sunlight to collect. But for the hundreds of millions of homes across the American Southwest, the Sun Belt, and the Mountain West with clear south-facing walls, the barrier is not geography. It is money. The global heating and window industries are worth hundreds of billions of dollars combined. They are built on a simple and ruthless model. Sell you a complex machine, charge you to install it, charge you to service it annually, charge you for the fuel it burns every single month, and replace the entire system every 15 to 20 years. A glass panel in front of a dark wall that heats your home for free for 50 years does not fit into this model. There is no installation contract, no annual service agreement, no monthly fuel bill, no replacement cycle, so the industry ignores it, and our building codes do the rest. American building regulations are written around certified mechanical heating systems with approved efficiency ratings and licensed installation requirements. A passive Trombe wall does not appear in these frameworks as a primary heat source. It is classified as supplementary at best, meaning that even if you build the most perfectly designed solar wall in history, a building inspector can still legally require you to install a full gas or electric heating system alongside it. You are compelled by law to purchase the product of the industry that wrote the regulations. And window manufacturers have no interest in telling you that a sheet of single pane glass in front of a painted concrete wall outperforms their $3,000 triple glazed unit in heating performance. Because it does, and they know it. But you can build this system today, without a contractor, without a permit in most cases, and for less than $50. Here is how. Step 1. Identify the south-facing exterior wall of your home that receives the most unobstructed winter sunlight. Step 2. Paint this wall matte black or dark brown. Dark surfaces absorb up to 95% of solar radiation. This single step alone will increase the thermal performance of your wall significantly. Step 3. Mount a simple single pane glass or polycarbonate panel approximately 4 to 6 inches in front of this dark wall using a basic timber or metal frame. Seal the sides to prevent heat from escaping sideways. Step 4. Cut a vent opening near the bottom of the wall and another near the top. These allow cool room air to enter the gap at the bottom and warm air to flow back into the room at the top. This is your convection loop. It runs itself. No fan required. Step 5. Install a simple hinged insulated panel on the inside of the vents. Close them at night to prevent the stored heat from radiating back out through the glass after dark. That is the entire system. A dark wall, a sheet of glass, 2 vent holes, and free heat every single day the sun shines for the next 50